Hello, Algebra 2 students. We're back to look at some more absolute value equations. In the previous video, when I showed you how to solve those, I told you that it was important to check the solutions and see if they work. Here's why. When we solve absolute value equations, and as we run into some other types of equations this year, we're going to see that sometimes we have the possibility for something called an extraneous solution. I'll show you what that means. It says, what is the solution of absolute value of 3x plus 2 equals 4x plus 5? Check for extraneous solutions. So what do we know about solving this? We know that we have to isolate the absolute value. That's already done, right? So we isolate is already done. Next is split. So I'm going to do 3x plus 2 equals 4x plus 5 and 3x plus 2 equals negative 4x plus 5. Remember, we have to put that negative there because the parentheses there because the negative applies to both the 4x and the 5. Okay, we isolate, split. Next thing is solve. So here I'm going to get the x's on one side. It does not matter if you subtract 3x or you subtract 4x. It doesn't matter. So now these subtract out and have 2 equals x plus 5. Subtract the 5. And I get negative 3. Okay. On this side, distribute the negative. Then I want the x's all together on one side, so I'm going to add 4x. Subtract the 2. Divide by 7. So I have two solutions, x equals negative 3 and x equals negative 1. Now, in the previous videos when we were solving, we said it was important to check these solutions, plug them back into the original equation and see if they work. Here's why. Okay, I'm going to give us some more room here. Erase this. My original equation, it's not erasing very well, was absolute value of 3x plus 2 equals 4x plus 5. If I take this negative 3 that we got and plug that in, everywhere we see an x, we replace it with negative 3. This is negative 9, right? Plus 2 is negative 7. 4 times 3 is negative 12. So here I have the absolute value of negative 7 equals negative 7. What do we know about absolute value and negative? Absolute value is always positive. It can't be negative. This absolute value of negative 7 is positive 7, not negative 7. So this one doesn't work. That's called an extraneous solution. Okay? Absolute value can't equal a negative. We got negative 3 when we worked this out, but when we plugged it back in, it did not work. That's called an extraneous solution. Now let's check this other one. I'll change color so you don't get it mixed up. So what are we plugging in for x this time? Negative 1. So we have absolute value 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. 3 times negative 1 is negative 3, plus 2 is negative 1. Here, 4 times negative 1 is negative 4 plus 5. Negative 4 plus 5 is positive 1. So this says the absolute value of negative 1 equals 1. That is true. So this solution works. So if you're answering a multiple choice question or you're working on your Savas Realize your online assignment, the only solution you would count would be the negative 1. This one is extraneous because it did not work when we plugged it back in. Okay. Let's see. I think we should have another one here. What is the solution of absolute value of 5x minus 2 equals 7x plus 14? Check for extraneous solutions. Okay. I'm going to actually go to a blank screen to work that. I'll have more room. 5x minus 2, 7x plus 14. Switch it up for you a little bit here. So absolute value of 5x minus 2. One caution too when you write these down is to make sure your absolute value bars are tall so they don't look like ones. 7x plus 14. Okay. First step is to isolate, but there are no numbers outside the absolute value bar on the same side of the equation, so we don't have to isolate. Split. 5x minus 2 equals 7x plus 14, and 5x minus 2 equals negative 7x plus 14. Parentheses because the negative goes to both terms. Okay, let's solve this side. Get all the x's to one side. Subtract 14. Okay, solve this side. Make sure this negative distributes to both of these. All the x's to one side. Add the 2. Now, we must check these to make sure that they both work, to make sure that we don't have extraneous solutions. So I'm going to take this negative 8 and plug it in for the x. This is negative 40 minus 2, so that's negative 42. This is negative 56 plus 14. What's negative 56 plus 14? It's negative 42. Can absolute value be negative? No, it can't. Absolute value of negative 42 can't be negative 42, so this solution doesn't work. This is an extraneous solution. It means you get it when you work it out, but it doesn't work when you plug it back in. All right, let's try this one. Oh, let me tell you, when you have two solutions like this, sometimes one of them works, sometimes both of them work, and sometimes neither one of them works. If they happen to both be extraneous, then your solution would be no solution. But you always have to check them both because sometimes one works, sometimes they both work, and sometimes neither one works. So let's try this negative 1. Let's go up here. We have absolute value 5 times negative 1 minus 2. Plug in the 1, negative 1 in for this x. Equals 7 times negative 1 plus 14. This is negative 5. Minus 2 is negative 7. Negative 7 plus 14 is positive 7. Can you see what I've got right here? Absolute value of negative 7 equals positive 7. That is true. That works. So this is a valid solution. X equals -1. That's why you have to check, because we have extraneous solutions. See you next time.